Well, congratulations on making your medicine and being a pharmacist. Now let's reflect a little bit. I'll read aloud. Measure the concentration of your oral suspension. Concentration can be given in grams per milliliter, or G/ml. Use the following equation to determine the concentration of your oral suspension. You will need your measured mass of powder in grams and your measured volume of water in milliliters, and a calculator to divide the mass by the volume. So you're going to use this formula here, and we need to go back up to the preparation chart to find the mass and the volume if you don't remember. So I'm going to go back up here. Now one of these you should have circled based on your baby's weight. So if your baby was between 0 and 200 grams, you should have circled this row here. And if you were a different weight, of course you circled a different row. Let's imagine our baby was between 0 and 200. I would use this 0.12 grams for my mass and 18.8 milliliters. So you could pause and fill in whatever your numbers were here. 0.12 grams and 18.8 milliliters. And make sure you use units. We want to get in that habit of always having a number with a unit, no naked numbers. Looks like I have 2 decimals there. That's better. All right, I'm going to jump to a calculator. Now in this one, we're just dividing. This is not percent error. We're just dividing. So it's 0.12 grams divided by 18.8 milliliters. And that will tell us how many grams in each milliliter. That comes to 0.00638. I'm going to round that to 0.0064. All right. Pause here if you need time to do that, and then we'll go on. Number 2, would you give this medicine to a newborn to help it get well, or would it make the child more sick? In other words, how confident are you that you measured both the solute and solvent accurately and have the correct concentration of medicine? So you just need to think about your process here. Think back to how you worked. Did you look at the water from eye level to make sure it was exactly there on the line or exactly where you wanted it to be? Did you use a pipette to be more accurate with the graduated cylinder? Are you sure if you used the syringe that you looked at the right side of that black stopper that moves through it? With mass, are you sure you zeroed out the scale so that the weigh boat was not part of your mass? Things like that. So pause here and write a sentence or 2 about your confidence in how you did with your measuring. And I will go on. Number 3, a regulator from the Food and Drug Administration, FDA, recently visited your pharmacy to make sure that all the pharmacists are accurately creating medicines for the patients who are babies. According to the regulator, an oral suspension made with less than 3% error is acceptable. Lower percent error is better, so they want it to be less than 3% for these babies. Look at the oral suspensions made by 3 pharmacists in your lab and see if you can figure out which pharmacist has an unacceptable percent error and needs further training to improve their accuracy. Calculate percent error for each oral suspension to find out. Here is our formula for percent error, and remember that we take the measured value, which is sort of like our value, or the pharmacist, their measured value, and then the accepted value is the right answer, the one that many people through a lot of testing have decided is the right answer. All right, so the our answer and the right answer, we want those to be almost the same or the same if possible. So let's look at Roberto. It says the accepted concentration is 0.0064 grams per milliliter, and Roberto's was 0.0063. That sounds pretty close, but when we're talking about these small numbers, it's hard to tell until we do percent error. So I'm going to type here. His measured is 6'3" minus 0.0064, and I'm going to divide that by the accepted again, 0.0064, multiply that by 100. So now I'm going to jump to that calculator again.
0.0063
Make sure you have all those zeros correct.
minus 0.0064.
Hit the equals sign after you subtract. Then divide.
Divide by 0.0064.
And then times 100. And I'm going to ignore the negative sign because that is what we mean by absolute value with the formula, so 1.56% error. The unit here is just percent or percent error. So let's think about that. Is he within the range? And if we look, they want less than 3% error, and he has less than 3% error with 1.56%. So it looks like Roberto's doing a good job. Go ahead and try that for the others. Please show your work so we can tell what you're doing wrong if you have mistakes. And then you're going to answer on the blank, which person needs more training to improve their accuracy? And pause again, of course. Number 4, think about the choices you made and your lab techniques. Rate yourself below. Put a check mark in the box that describes your comfortability or how comfortable you are with each lab technique. So using the lab skill, finding the increments on a graduated cylinder or syringe, measuring accurately using a graduated cylinder or syringe. Just put a check mark in the box that applies to you for each of those. Do you think you still need a lot of practice, or you are getting good at this, or you can do it very accurately? And then submit that to 4.3 CHEW. Thanks.